Mice pie. Mice never tasted so delicious.
Okay, once upon a time, a virus was spreading throughout the kingdom. It was known that 1 in every 100 people were infected. The king's top scientists developed a quick test after working together for many days. The test never fails to detect the virus if any is present. Otherwise, it is still highly reliable, returning accurate results 90% of the time. The king was pleased with the test and decided to test everyone in the kingdom. On the first day trying it out, many people were lined up to receive this test. Negative, 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 and so on, until finally poor Joe became the first one with a positive test result. Joe felt very sad about this test result, and everyone else were scared and tried to stay away from him. The king decided to exile Joe from the kingdom. However, a wise man stopped the king, saying that the chance that poor Joe were truly infected was very low. The king asked, "What is the chance?" The wise man think about it and responded saying, "Less than 20%. Now, is this wise man correct? Can you find the probability that poor Joe is actually infected? Stop this video if you want to try figure it out yourself. Please like this channel. Now let's try to solve this problem. Intuitively, it seems that poor Joe should be exiled since the test is correct most of the time. Shouldn't you be able to trust its rating? Unfortunately, no. Let's explain why. Imagine the kingdom has exactly 1,000 people. 1 in every 100 were infected. That means there are only 10 people who were truly infected. All these 10 people would have positive test results, since the test always detects the virus if it is present. What about the other 990 people in the kingdom without being infected? Now, the test gives the correct result 90% of the time if a person is not affected. So 90% of them, 891 people to be exact, will be tested negative. But 10% or 99 people out of them will be tested positive despite not being infected. This is a result known as false positive. Now, that means all in all, there are 10 plus 99 equals 109 people will be what? Tested positive. Poor Joe is just one of them. From the 10 who are truly infected to the 99 who are not infected but with a positive test result. That means the chances that per Joe being infected with this virus are simply 10 out of 109. That's about 9%. We see that this chance is below 20%. Now, you may ask, why is this result so unexpected? The key is something called the base rate fallacy. While we focus on the accuracy rate of the test, we tend to forget how rare this disease was in the first place. We know that the test is reliable. Even though the accuracy rate of the test is high, 90% of the time for the unaffected people, the number of false positive test results can still be very high due to the large number of uninfected people. Therefore, every time we get a positive test result, the probability of being a false positive is still greater than a real finding. This is an example of conditional probability. Here, the overall chance of being infected with the virus is probability of A is 0.01, 1 in 100, without any condition. This is called the Posterior probability. However, what we are trying to find is the chance of being infected given that we got a positive test result. That is known as the conditional probability, or the so-called posterior probability. Well, in many cases, it is better to be safe than sorry. However, false positives can have real negative consequences. For instance, in medical tests, a false positive happens when one healthy person is tested positive for a disease, such as cancer. Now, as you can see, such false positive testing result can lead to what? Stress or sometimes unnecessary treatment, which can be bad for this person's health. Now, another example, in a court trial, a false positive happens when an innocent person was claimed guilty. Now, in this case, it can cause this innocent person to be wrongfully punished, jailed, or even killed. Before you leave, why don't you try the following problem? Now we have it is known that 1% of the rocks in a mine contain gold. A device can detect gold 95% of the time if gold is present. If a rock doesn't contain gold, the device will give correct reading 90% of the time. Now, a rock is randomly selected from the mine given that the device detected gold in this rock. What is the probability that it doesn't contain gold? Can you solve this problem? Give it a try and leave a comment below. Thank you for watching. See you next time.